The ship sailed 3 kilometres west, then 2 kilometres south. So what we need to do here is our little north, south, east, west to start off with. So we know that's north, south, east and west. And we're told that the ship goes 3 kilometres west, which would be out this way. That's 3 kilometres. And then 2 kilometres down south. You don't have to be to scale. And of course that's where my right angle is going to be, horizontal with the vertical. This is my starting point, and this is where the ship ended. So this is from the ship to the starting point. So we are looking for the 3-figure bearing from the starting point to the ship. So this is the bearing that we are looking for. That's going to be the 3-figure or the true bearing. Obviously, we need to know what this angle in here is, because that will help us find our true bearing. So let's see how we go about doing that. Okay, so what do we know? We know that we have the adjacent and we know that we have the opposite. So we're going to use tan theta, which is opposite over adjacent, which in this case would be 2 over 3. So theta is equal to the inverse tan of 2 on 3, which is equal to 33.69 degrees. Now they want it to the nearest degree, so it's approximately 34 degrees. Now that's not our true bearing. And just remember, your calculator needs to be set to degrees if you're not getting the right angle. Alright, so the true bearing, therefore, is the blue bearing that I'm looking at. So it's going to be, every quarter is 90, so it's 90 plus that extra little bit, which would be 56 degrees. Okay, so in total, therefore, my true bearing is 236 degrees true. Now remember, a true bearing must have 3 digits. So that was part A. Part B, okay, we are now looking for the bearing of the, so for a person on the ship, what would be the 3-figure bearing looking back to the starting point? So here's the ship. Okay, there's the ship. I do another little north, south, east, west there. And this is looking back to the starting point. So I'm looking for that angle in there. How would I go about finding that angle in there? Well, what do I know? All the angles in a triangle add up to 180. So how about I take away from 180, 90 degrees, and the green angle, which, sorry, that wasn't 34, it was 56 degrees, which means that now I have an angle of 34 degrees. True. Remember, 3-digit bearing must have 3 digits in it. Put the 0 at the front. 034 degrees. True. True bearing starts from the north, goes around in a clockwise direction. This is question 4. An aeroplane flew 500 kilometres south, then 600 kilometres east. So let's do our little north, south, east, west again. Alright, so it flew 500 kilometres south, which is down this direction here. That's my 500 kilometres. And then it flew 600 kilometres east. So it came this way to 600 kilometres. So the question asks, give the 3-figure bearing from the starting point to the nearest degree. Starting point is up here. So I'm going to go back there from where the plane finished, and I want the 3-figure bearing from the starting point, which is this one here. Now, obviously, if I can get this angle in here, it will help me to work out my 3-figure bearing. So what do I have? Well, there's my right angle. I have the opposite, which is here. I have the adjacent, which is there. Okay, so it's going to be tan again. Tan theta equals opposite over adjacent, which is 600 over 500. Theta is equal to the inverse tan of 600 over 500. Okay, and when we work that out, we get 50.19, which is approximately 50 degrees. So what we've got is an angle of 50 degrees there. So we know, therefore, that if this is 50 degrees, then this little bit in here must be 40 degrees. So therefore, the true bearing from the starting point would be 90 plus 40, which is equal to 130 degrees. And don't forget your true on the end.